Welcome back. This is another exciting episode of Mr. Takeda Teaches Algebra. I'm your host, Mr. Takeda, and I'm going to teach you some algebra. This is lesson 7.1 on adding and subtracting polynomials, in which we ask the question, how do you add and subtract polynomials? Well, let's start off with a little vocabulary. And the first thing we need to know is that a monomial, now think about where you know the prefix mono from, and of course it means one. A monomial is a number, variable, or product of numbers and variables with whole number exponents. So things like the number 5, that could be considered a monomial, and of course the variable x could be a monomial. It's the product of numbers and variables. So 5x could be a monomial. But something like 5 divided by x is not a monomial because why? Well, because that's equal to 5 to the power of x to the power of -1. And the variables have to have whole number exponents. So anything with a fractional exponent, anything with a negative exponent is not a monomial. Anything that has a plus or minus in it, like an addition or subtraction, is not a monomial because it has to be a product. So something like 5 plus x is not a monomial because it's not a product. This is, of course, a sum. Okay, so the next thing we want to look at is degree of a monomial, and it's the sum of the exponents of the variables. So we'll run through a few examples here. Find the degree of each monomial. Well, for this variable, we have an exponent of 2, so the degree here is 2. We have two variables in this monomial, x and y. Well, that really has an exponent of 1, doesn't it? So the sum here is 4. So the degree here is 4. The degree here is 6. The degree here is actually 0. Because think of this as like x to the 0 power, right? Any variable to the 0 power is just equal to 1. Any constant, any number without a variable has a degree of 0. Okay, let's talk about polynomials. Let's think of the prefix poly, meaning many. A lot of times I'll ask my students in class where they've heard this before, and in 6th grade, when they study world ancient civilizations, they come across the term polytheism, which of course means the worship of many gods. Poly meaning many. Okay, so poly means we're going to be adding monomials because we're adding one or more monomials. So a polynomial is a monomial or the sum of monomials. So think of polynomials as think of polynomials as kind of an overarching term that includes monomials and other types such as binomials, bi meaning 2. A polynomial has 2 terms as a binomial. And a polynomial of 3 terms we call a trinomial. So things like tricycles and triangles. Tri meaning 3, bi meaning 2, like bifocals, glasses that have 2 sets of lenses in them. Binomial. Okay, so binomials would be 5x plus 2. Trinomials would be like x squared plus 5x plus 2. These are the terms of the polynomial, the things that are added. Okay, when I say terms, think about the things that are added. So if I was to say x squared minus 2, my terms would be x squared and negative 2. Because what's happening here? I'm adding a negative 2, right? So that's a term. Degree of a polynomial is the greatest degree of its terms. So in the case of this trinomial here, the greatest degree is 2. This has a degree of 2, a degree of 1, a degree of 0. So the degree of this trinomial would be 2. A polynomial in one variable is in standard form when the exponents of the terms decrease from left to right. So Again, this trinomial, the example trinomial here, is in standard form because the exponents go from 2 to 1 to 0. This is standard form. Many times it's easiest to work in trinomials, in polynomials when they're in standard form. Also, we'll call this descending order. Descending order. When you write a polynomial in standard form, the coefficient of the leading term is called the leading coefficient. So let's look at this 4-term polynomial here. This is a third degree polynomial. Its leading term is 2x cubed. This is the leading term. And the leading coefficient is the coefficient of that leading term. So in this case, the leading coefficient is the 2. Okay, so there's some vocabulary things for you. Lots of vocabulary in this section, for better or worse. Sometimes that's easier for you guys. Let's write a polynomial in standard form. We'll write 15x minus x cubed plus 3 in standard form. Identify the degree and the leading coefficient of the polynomial. Okay, so I said terms are the things that are added. So think of the terms as being split up this way. So my leading term is going to be negative x cubed plus then 15x and then plus 3. The constant always goes last. The degree, this is a third degree trinomial. The leading coefficient is negative 1. Negative 1 because negative 1 times x cubed gives us that negative x cubed. Okay, just a few more words here for you because you're gonna run across some of these things. We already talked about monomial, binomial, and trinomial. Typically, when there's 4 or more terms in a polynomial, we just call it a polynomial. Okay, these are, up here we have some other words that describe polynomials by degree. If it's a first degree polynomial, in other words, the greatest exponent is 1, it's linear. We've already done linear equations, things like 3x plus 5. Well, that exponent is 1, so that's linear. Quadratic is second degree, so we're going to be doing more of these types of things in the following chapters, I believe. But if we had like 3x squared plus 2x plus 5, it's a second degree polynomial because the greatest exponent here is a 2. It's called a quadratic. Think of quadratic as square, right? Quad means square. So we're squaring that. Cubic would be a third degree. So the highest exponent would be a 3. Fourth degree is quartic. The highest exponent is a 4. So these are some other words that describe first, second, third, and fourth degree. There is a fifth degree, I believe, called quintic, but we're not going to be using that term in this class, as far as I know. Let's move on. Classifying polynomial, we want to write these in standard form, identify the degree, and then classify by number of terms. Okay? So here I have negative 3 is e to the fourth. It's already in standard form, the largest exponent. There's only one here. This is, of course, is a monomial. It's a fourth degree or quartic monomial. B. The 5x squared is going to go first. Then the negative x, because remember, things that are added. We're adding a negative x. Terms are things that are added. Then the plus 4 constant goes last. Highest degree here is 2. This is a quadratic trinomial. And then last here, 8q plus q to the 5th. This will be q to the 5th plus 8q. And this is a 5th degree binomial. Pretty straightforward. We want to just classify by degree and number of terms. Adding polynomials. Finally, we're going to get to the part that we're asking about here. Finding the sum. When it comes to adding polynomials, you're going to see the polynomials are kind of written separately in with parentheses. Okay. When it's adding, you can just ignore the parentheses. Everything, you just add everything together. You're combining like terms, right? Combine like terms. Okay, so I have 2x cubed, and I have 1x cubed. So that's going to be 2 plus 1, 3x cubed. And I try to go in descending order as I add. You don't have to. You can add them up and then put them in descending order. Typically, you're going to be asked to put your answers in descending order. My squares, I've got negative 5x squared plus 2x squared. So negative 5 plus 2, negative 3x squared. Then I have just an x and just a negative 1. So plus x minus 1. We're just combining like terms. Second example here, 3x squared plus x squared, 4x squared. X and 4x, 5x. And then negative 6 plus 10, we can constants are like terms, so we can combine those as well. Negative 6 plus 10 is 4. Pretty straightforward. Adding polynomials, pretty straightforward. Subtracting polynomials. Here we want to add the opposite. I want you to think of this in the same way we do integers. So I'm going to rewrite these as addition. So the first polynomial, in this case a binomial, stays the same. I'm going to write this as addition. And now I'm going to write the second polynomial as the opposite. Now every term in here has to be the opposite. So negative 2n squared becomes positive 2n squared. Plus 2n, positive 2n becomes minus or negative 2n. And then minus 4, negative 4 becomes positive 4. Okay, so negative, positive, positive, negative. So now I'm adding the opposite. And now I can just combine like terms, like I did in the previous example. 4n squared plus 2n squared, 6n squared. Negative 2n. Sorry about that. The negative 2n, there's no like term for the negative for the n, so that's going to be by itself. Negative 2n. And then I've got 2 constants here, 5 plus 4, so that's just 9. Okay. And then for the next example, I'll do just one more example here. Again, the first polynomial stays the same. This becomes addition, and then I'm going to rewrite this as negative 3x squared plus x plus 8, adding the opposite. And that means the opposite of every term in here, because now look what happens if I add these together. Those cancel, those are 0, negative x plus x, 0, negative 8 plus 8, 0. What's the definition of opposite terms? Of opposite? If I add them together, I get 0. So now if I add these two together, I get 0. So remember, the opposite of every term inside the second polynomial. It's got to be the second one. Okay, so I've got 4x squared plus negative 3x squared. So that's 1x squared. Then for my x's, negative 3x plus 1x, negative 2x. And then 5 plus 8, 13. All right? And that's it for now. I know there's a lot of vocabulary in this, so this took a little bit longer. But hopefully you learned something. That's a start for Chapter 7. Lots of polynomial work. We'll see you in class. This is Black Widow, by the way.